So we looked at multivariate regression, okay? And we saw also we consider two methods that are used for regression analysis in Excel. What are those two methods? What are the two methods used? Do you remember?
Since univariate and multivariate.
No, those are types. I mean, what are the two approaches for? Okay, let me give you one of them. One is by using scatter plots. What's the other method?
I use histogram as well.
No. You can use data analysis to data analysis. This one.
Okay, okay.
Or scatter plots, one out of the two. Okay, so
Yes, sir.
today we're going to look at a third method. Another method you can use for your regression analysis. Okay. Okay. Now, which of the two methods would you consider more robust, more detailed?
It's data analytics too.
Data analysis too, yeah, it's more robust. It's more detailed, more professional. Okay.
Yes, give you more information about
Gives you more
data sets.
more details in the result, in the reports, in the output. Okay. Yeah. Now we are going to look at the third method. That is by using what is called the Linest function. The Linest function. Okay. So we worked on this data before. Worked on this very data before. So I'm going to use this to illustrate. Let me delete this output. Okay, so we can use the Linest function also for regression analysis, for linear regression. Okay. The output, now the regression analysis is actually an array function. The output, why? Because it produces multiple outputs. Okay. The output usually displayed in a 5x2 matrix or array like this. 1, 2, 3, 4, 5 rows, 2 columns. Okay. So to use the function, you start by selecting the cells, the range where you want the output to be displayed. That's the first thing you do. And then you click in the formula bar and go ahead to type your function. Okay. So you click in the formula bar and say equals what? Equals what?
Equals Linus.
Thank you. I call the Linus function. So you have to start with equals Linux. And then Excel will guide you on what to do from there. First of all, it's asking for what? Known Ys. What are the Ys? Sales, right? You highlight the sales. What next? Known X. You highlight
Yes.
the
Yeah, but
adverts. comma. Now it's asking you, do you want to first set the intercept to be 0, or you want the intercept to be calculated normally? We want it to be calculated normally. Don't want 0. The next is asking another question. Do you want return additional regression statistics? Do not return additional regression statistics. Do you want it to give you detailed results? Yes. Then this is an array function, right? So you have to hold down Shift Control and press Enter. Okay. Usually when you are using this kind of functions that display multiple results, that's how to do it. You hold down Shift Control, Enter. So it gives you some details, right? But it doesn't say what these things mean. That's why I have written it out here for you to see. Okay. So what it's telling you is simple. It's saying that this one, you see it, that's the slope, line slope. This is the intercept. This one is the slope standard error. This one is the intercept standard error. When we start, by the time as we move on to hypothesis testing, we'll talk about these details, standard error and all that. This one is R squared. Remember our R squared was 76%. This is standard error of Y. This is F stats. This is degree of freedom. This is sum of squares of regression, sum of squares residuals. So what's like I was saying, what we are most interested in are this line slope, the intercepts, and what? R squared, right? Remember.
Yes, sir. Line slope, intercept, and arrow square.
Yes. So what do you think the equation is here now? Can you give me the regression model? What's the regression model from this output?
So y is equals to
Equal to what? You know, you say y is equals mx plus c, right?
yes.
So what do you think m is here?
M is this slope, yeah.
18.71, and c is equals what? 13.
Intercept.
Let's say 13. Let's use two decimal places, I mean,
83.
0.83. And that's all. So our job is done. So what's the model? Y is equals what? 18.71x plus what? 13.83. That's it. So let's have to use the Linest function. Okay. if you were to use what do you call it? If we were to use scatter plot, would you have gotten the same thing? Do you think it's the same thing?
I think it should be the same thing.
Okay. Look at it. See what we got from the scatter plot. Y equals 18.70 something x plus 13 point that. Is it the same?
Yeah,
Yeah,
the same.
the same. Same, exactly the same.
Yes.
Exactly the same.
The same thing.
Okay. So this is how the Linux function works. Okay. So you can decide to use that as well.
Yeah. So if we're given the S, then we can calculate the Y. If we're given the Y, we can calculate the S. Yeah.
Exactly, using this equation.
Okay.
Okay. So then look at this. Now, suppose, let's go back to the scatter plots. If we use what do you call it now? Here's our equation. Okay. Let's see what happens when we use exponential. Exponential. If you use exponential, and we display the equation for the exponential and r squared. Can you see it? Can you see this one?
Yes, sir. You can see it.
Okay.
Yeah. But here the R square is higher
Yes.
compared to the linear.
Yes. So if we were to use exponential, you can see the equation. What's the equation here? Y equals 18.869 E what?
To the power of 0
0.4
point.
or something. Okay. Can you see it?
Yes, sir.
Okay. To the power of 0.4921x. Okay. So now let's go back and talk about another function. Now let's talk about what they call the logest function. This is for exponential curve, right? It's the same thing, but when you are doing exponential, that's when you use this one. When you are doing exponential regression, that's when you use it. And this is what their output is. It corresponds, this coefficient of, this is slope, this is coefficient of, this is intercept, r squared, just the same thing. But the thing is that this one is for exponential, right? And your output is also 5/2, okay? So now let's try to apply it to this. I'm just trying to show you how both works, both the Linux and the Logest. Linux is for linear regression. Logest is for exponential regression, which are the three popular types of regression, especially linear. Linear is the most popular. Okay, so now we are going to use the logest function now. Now you tell me what to do. Step one. Just like Linest function. What's it? Are you sure?
Okay, yeah.
Okay, step one, you highlight this range where you want the results to be displayed. Step two, you click in the formula bar. Don't type it here. If you type it here, if you attempt to type it here, it will not, if you do this, you see, are you following? To ensure that it stays in place, you walk 1, 2, 3, 4, 5. You walk in the formula bar to ensure it stays in place. Okay? Although you could also do that anyway. But don't click again. After highlight, if you click again, this highlight will disappear. Say logest. You open your brackets. It's asking for the known y's. You highlight the y values. Known x. You highlight the x values. What is it asking for again? It's asking if this should be calculated. Yes. What is it asking for here? It's asking if you want details. Yes. Shift Control Enter. So let's examine the output now and try to form the equation. So this is your output. This is the intercept. This is the coefficient of what? X. This is the slope, which is the coefficient of x. Then this is what? R squared, right? Is that right?
Yes, sir, you're right.
Okay. So that is it. So can you form the equation from this? Should I allow you, should I give you time to formulate the equation for me?
Okay.
Try to formulate the equation.